Okay, so today we're going to be looking at the MANOVA. This is without the DFA. First step is analyze general linear models multivariate. Step 2 is we move the dependent variables into the dependent variables, and then the group is in fixed factors. We're going to model just to make sure that it's full factorial and the sum of squares is type 3. Click continue. Go on to plots and move the group over to the horizontal axis and add. You can either have a line or bar chart here. Make sure the y-axis starts at 0. Continue. We then go to the post hoc and move the group over to the post hoc test 4. And in this example, we're using Tukey because the sample sizes are equal. If they're not, we'll use the Bonferroni. Again, click continue. This time we go to options. We take the descriptive statistics and homogeneity tests, click continue and OK. Next step is now we have our output window. We look at the between subjects factors and we know our sample sizes are equal. So later we will be using the Pillai's trace. If the sample size is unequal, we would be using the Wilks-Lambert. Box's test of equality of covariance matrices. For this, we want the statistic to be non-significant, meaning the probability level should be greater than 0.001. This example is 0.697. This indicates that there are no significant differences between the covariance matrices, hence assumption not breached. How we write it is boxes M equals 4.316, F6 18169 equals 0.642, and the p-value is 0.697. Next, we'll be looking at the multivariate test table. We have previously identified that we'll be using Pillai's trace. We can conclude that the f value for Pillai's trace is significant. This indicates that there is an overall difference in the combined collective dependent variables across the groups. We write it Pillai's trace equals 0.468, F454 equals 4127, p equals 0.005. So when looking at the tests of between subject effects, first thing we do is check the significance value in the group row for the dependent variable, 0.70. Its degrees of freedom are 2 with an error of 27, and we report the f value of 2.946. For this dependent variable, there are no significant group differences in intentions to exercise after school. The next dependent variable, we look over and see 0.02, so it is significant, and again we use the 2 and 27 and report the f value. So there are significant group differences in physical activity behavior after school, and you say f2 27 equals 8.203, comma p equals 0.002. We look at the Levene's test of equality of error variance. We use the based on mean row to check the significance. If there are non-significant, then we can assume equal variance, and we would report this. Neither of the variables recorded significant values. Intentions significance is 0.669 and physical activity significance is 0.569. Both are non-significant. Therefore, we can assume equal variance, and we report this with f2 27 is smaller or equal to 0.576, and the p-value is bigger or equal to 0.569. Looking at the multiple comparisons table, we do one dependent variable at a time. You look for the significance, report if there are any significant group differences for that dependent variable. For intentions to exercise after school, there are no significant group differences in the age group for intention to exercise after school. We will then repeat this with the second dependent variable. There are significant group differences in the age groups in physical activity behavior after school. 12-year-olds take part in more physical activity than 14-year-olds and 16-year-olds. We then use the descriptive statistics to report this. The mean difference between 12-year-olds and 14-year-olds equals 2. The p-value is 0.004, and it's 4.9 versus 2.9. The mean difference between 12-year-olds and 16-year-olds equals 1.9, with a p-value of 0.006, and it's 4.9 versus 3. A one-way between groups multivariate analysis of variance, MANOVA, was performed to explore the difference in the intentions to exercise after school and actual physical activity behaviour after school among 12, 14 and 16-year-olds. All the assumptions, including the homogeneity of covariance and homogeneity of variance, were confirmed. A significant multivariate test statistic was obtained. Pillai's trace 0.468, F454 equals 4.127 with a p-value of 0.005, indicating that a significant difference existed across the three age groups. A follow-up univariate F-tests identified significant group differences in physical activity behavior after school. A Tukey HSD post hoc tests revealed that 12-year-olds reported greater physical activity behavior after school compared to 14 and 16-year-olds. When looking at the covariance matrices, you read it from top right, diagonally left. So for 12-year-olds, it is minus 0.89. This shows that there is a negative correlation in 12-year-olds between intentions and behavior, which suggests that as a behavior increases, then intention decreases. The next one is for 14-year-olds and has a score of 1.8. There is a positive correlation in 14-year-olds between intentions and behavior, which suggests that as behavior increases, so does the intentions. The last one is for the 16-year-olds with a score of minus 0.444. There is a negative correlation in 16-year-olds between intentions and behavior, which suggests that as behavior increases, then intentions decrease. The eigenvalues shows how much variance in the dependent variable is accounted for by the function. A quick note is the maximum number of discriminant functions reported is the amount of groups minus 1. We have 3 groups, so there are 2 discriminant functions. Function 1 has an eigenvalue of 0.680, which is large. In fact, it is 10 times larger than the second function, which has an eigenvalue of 0.068. The first function accounts for 90.9% of the variance, and the second function accounts for 9.1% of the variance. This suggests that function 1 is the dominant discriminant. If we square the canonical correlation, function 1 equals 0.636 and function 2 equals 0.252, we derive the effect size. Function 1 equals 0.40 and function 2 equals 0.06. The Wilks-Lambert table shows the statistical significance of both functions, 1 through 2, and when the first function is removed, 2. The groups can be discriminated by 2 functions, p equals 0.004, but not one function, p equals 0.187. So we're going to write this as the Wilks-Lambert score, x squared, with the degrees of freedom in the bracket, then its chi-square, and then followed by the p-value. You would write this as Wilks-Lambert equals 0.557, x squared 4 equals 15.485 with a p-value of 0.004, and Wilks-Lambert 0.936, x squared 1.739, p equals 0.187. When looking at the structure matrix, we are looking for the score that is closest to either -1 or +1. For function 1, we see that physical activity has the highest score with 0.939, and for function 2 is the intentions to exercise as the highest score with 0.868. The way we would write this is physical activity 0.939 contributes most to function 1, since 0.939 is closer than 0.49621. Intentions to exercise 0.868 contributes most to function 2, since 0.868 is closer than 0.334 to 1. We would write this as a whole by saying the physical activity has a negative relationship with function 2. This is the minus 0.344, whereas intentions to exercise has a positive relationship, 0.868. This means that function 2 differentiates groups by some influence that affects intention to exercise and physical activity differently. In contrast, function 1 differentiates groups by some influence that affects physical activity. 0.939 and intentions to exercise 0.496, but in a similar way. When looking at the functions at group centroids, these are the mean function scores for each group and are plotted on the combined group plots, which are labelled canonical discriminant functions. We would write this up by saying the centroids and the discriminant function plot show that the first function differentiated the 12-year-olds from the other two age groups, whereas the second function differentiated the 14-year-olds from the other two groups. Overall, the first function separated the groups more than the second function. Classification results. First thing we do is we look at this line at the bottom, which shows us that overall, almost 57% of the cases were correctly classified. Then we go over to the 12-year-olds and look at the section to see that the discriminant functions accurately classified 80% of the 12-year-olds to their actual group. We then go to the 14-year-olds and see that only 30% of the 14-year-olds were accurately classified to their actual group. And then we can see it also accurately classified 60% of the 16-year-olds to their actual group. However, for the 14-year-olds, the discriminant functions misclassified 30% to the 12-year-olds group and 40% to the 16-year-olds group. Similarly, for the 16-year-old group, it misclassified 30% to the 14-year-olds group. So now it's time to write it all up. We start by using the information that we've got from the eigenvalue, and we say the MANOVA was followed up by a discriminant function analysis, which revealed two discriminant functions. The first function explained 91% of the variance, canonical r squared equals 0.40, whereas the second function explained only 9% of the variance, canonical r squared equals 0.06. The next section is the information we've got from the Wilks lambda. In combination, these discriminant functions significantly differentiated the age groups. Lambda equals 0.557 x squared brackets 4 equals 15.485, p-value equals 0.004. But removing the first function indicated that the second function did not significantly differentiate between groups. Lambda equals 0.936 x squared brackets 1 equals 1.739, p equals 0.187. The following section is the information we've got from the structure matrix. The correlations between outcomes and the discriminant functions revealed that the intentions to exercise loaded more on function 2 compared to function 1. And then in brackets is r equals 0.868 compared to r equals 0.496. However, physical activity behavior loaded more highly on the first function compared to function 2, r equals 0.939 compared to r equals minus 0.334. The next section is based off information we've got from the functions at group centroids. And we say the discriminant function plot showed that the first function differentiated 12-year-olds from the other two age groups, whereas the second function differentiated the 14-year-olds from the other two groups. Overall, the first function separated the groups more than the second function. In the final section, we get our information from the classification results. Approximately 57% of the cases were correctly classified, 80% of the 12-year-olds were correctly classified, 60% of the 16-year-olds were correctly classified, but 30% were misclassified as 14-year-olds. Only 30% of 14-year-olds were correctly classified, but 40% were misclassified as 16-year-olds, and 30% were misclassified as 12-year-olds.